Well, here's a little bit of an intro to using ChemDraw to make structures. You can see on the right hand side we've got menus to choose from. For example, I can draw benzene ring, I can draw cyclohexene, and many other varieties. If I want to delete these, I just run an eraser over them, or if I want to delete them, I can select the entire document or the entire structure, hit delete. I also can choose single bonds. I can make a structure with different carbons. I can hit this little broom button and it kind of cleans up the structure. I can tap a bond and make it a double bond. I can tap a bond twice and make it a triple bond. If I keep tapping, it'll cycle through single, double, and triple for carbon-carbon bonds. I tend not to use these structures though. I tend to use kind of a more classic, what I would call a Lewis structure. Just my own preference. So I'd like to show you how I do that. It took me a while to figure out the best way to make these structures. And here's what I'm doing. Let's say I'm going to make butane 2-ol, the secondary alcohol of butane. I'm actually going to draw it like this. Oops. Now I kind of like my geometries to be about right. There's my second carbon, third carbon, fourth carbon, and sort of in a classic structure, these are all carbons. This is a massive structure, but I can actually label these atoms. And if I choose hydrogen, I can label these atoms as hydrogen. And then if I grab an oxygen, I can label it OH. Or if I prefer, I can make a bond from the hydrogen, or from the oxygen, and I can attach a hydrogen to the end and I can show the entire OH. I can also show lone pairs on the oxygen if I so choose. I can zoom in and out to make it bigger or smaller. I can put reaction arrows if I want to have a reaction happen. I can show electron pushing if I'm drawing a mechanism, and yes, I'm not being specific to an actual mechanism here. I have equilibrium arrows. There are a lot of choices for options, if you will, within ChemDraw. I can also draw more traditional Lewis structures of inorganic molecules. If I want to draw O2, for example, I just draw a double bond, make both of these oxygen. If I expand this a little bit, I can add some lone pairs to this oxygen just by tapping on the oxygen. I also, if I select the molecule, make it a little bit smaller, I can rotate it. If I want to change the orientation, and I find that to be a nice feature. Now, another one, for example, that I'd like to show you is Boron Trifluoride. I can put fluorine around the center atom, and there's these atoms that I can choose from here. If I choose the periodic table, I can choose boron, put that in the center atom, and there's boron trifluoride. Now, of course, if I'm really making a true Lewis structure, I need my lone pairs around the fluorine. So if I just tap the fluorine a few times, I get the lone pairs around fluorine. How do I use these? I often insert them into my PowerPoints that I use during class discussions. If I hit this export button, I can save it to my camera roll, and then I can import it from there, depending on how you're producing your PowerPoints or your whatever notes you're going to use in class. You can also send yourself a mail with the picture. You can put something up on Twitter. There are a few different options. I tend to save the image to my camera roll and use it from there, or mail it to myself. And I find that for every image, it takes me a total of maybe 10 seconds to save it, email myself, get it from there, and put it into my PowerPoints. Are there more efficient ways to get the images? Yeah, probably. I just haven't found them yet, and I don't find myself too inconvenienced by this method. So until it becomes a real hassle, I'm just going to roll with it. If you're working on ChemDraw and you know a better way to do this that makes it a bit more efficient, I'm always interested in learning that. There are a few other nice features of ChemDraw that I've used. For example, if I want to draw the ammonium ion, you can see here it showed me with nitrogen there's an error. The structure contains valence electrons, and that's okay. I'm going to put it in brackets. I can create the brackets here, and I can also give this a positive charge if I want to show that it's an ion. I'd love to see a positive charge that doesn't have a circle around it. I'm just kind of, I don't know, that's my own preference. But you can, there are different brackets you can use. You can also type something here if you want to add something to a document to show a sequence. If I create a new document, just showing you there are orbitals I can draw. There are shapes I can draw if I feel like putting a shape on here in order to highlight a structure and then putting a molecule within that. I can even turn this into benzene if I forgot. Lots of options for using ChemDraw. I hope you found this helpful. It's relatively simple introduction to ChemDraw, and I'm going to reiterate sort of one point that took me a while to figure out. And I've said this earlier, and it's just because of my own preference for how I draw Lewis structures, but it took me a while to figure out how to get the hydrogens and the oxygens and the carbons to all work. I like to draw relatively kind of sound structures, and see if you can figure out what I'm going to draw here. So if I put carbons here and here, oh, and I'm missing something here. I forgot. I wanted to put, I wanted to put a double bond there. That's kind of odd. It's doing a triple bond in a weird sort of way. Well, let's try this. And this is one of those things that I've kind of figured out over time is I'm not always perfect with the way I use ChemDraw, and I just try and work it out. I want to make this an oxygen. I want to make these hydrogens. I wanted to draw an ester. Can I figure out what's going on with my oxygen there? Well, not really. So if I delete it, if I delete that, and I make this, make this a double bond. My point here is I'm not perfect with ChemDraw, but if I just play around, I often end up figuring out what I'm doing wrong. You can't break the software. You know, if you do something wrong, delete it, try again. I offer this just as a way of encouraging you to just go for it. Do you like lone pairs on your Lewis structures? Clean it up. It'll show you a different geometry. You can always undo it if you don't like the way that it cleaned it up. Nice little feature here. It'll tell me what the formula is, what the exact mass is, the molecular weight, elemental analysis in terms of percent carbon, percent hydrogen, percent oxygen. Might be nice for setting up practice problems if you're setting up an empirical formula practice problem or something like that. So I've rambled a little bit here, and I did that. I didn't mind making a couple mistakes there though, because I just wanted to show you that it's easy to recover from mistakes. You do something wrong, you just erase it and come back to it again. As I said earlier, I hope this has been helpful for you. I have found that this was a $10 purchase that was well worth the money, because this is far better than my chicken scratch handwriting that students find difficult to read. I find these structures significantly better. What I'm not doing yet is using my iPad and ChemDraw sort of on the spot to teach. I know there are some people out there that do that. I have just found that I'm not quite comfortable enough yet to show mechanisms, for example. I tried it just the other day to practice a little bit with a mechanism, and I found the arrow pushing a little bit challenging in terms of setting it up, and maybe I just needed more practice. One of my goals for next year is to show mechanisms on my iPad draw them on the spot so that the students can see a nicer representation of a mechanism than the bad handwriting that I mentioned earlier. I've rambled some more. Well, that's all for now. Certainly leave comments if you've got suggestions or questions. I'm happy to try and answer. There are some good resources out on the internet to learn how to use ChemDraw as well. Let me know what you think. Have a great day. Thank you.